Hello all, today in this video I'm going to show a demo of an support vector machine classifier which is going to classify iris dataset. In this channel previously also we have made this code, but previously if you're seeing means we have made this code with different kernels. The first we used is linear kernels, second is RDF, and the third we are going to see is sigmoid. So as in every Python code we are going to import libraries. So in order what are the libraries we are going to use in SVM or pandas and sklearn. In sklearn we are going to import train test set and SVC, since we are using support vector mission. So then we can just run this libraries. Then we have to read the iris dataset. Since the iris dataset we are using is an CSV file, we are just using read underscore CSV, and just now we can just run this code. So it has also completed, that load data set has also loaded. Then we have to import the features in the X label and also the Y label. X label is going to contain take the values of sepal length, then sepal width, then petal length and petal width, and then Y is going to classify the species. So by using this X label and Y label, we are just creating an X train, Y train, X test and Y test dataset by using the SVM train test split library. So here or previously the test size is 1.1. 0.1 is testing percent is 10% and training percent is 90%. But now I need testing percent as 20. So I just change the test size as 0.2, and if so means the training percentage will be 80%. So then we have to just run the code. So we have just created four variables like X train, X test, Y train and Y test. Now we are just running this SVM model. For that I am just using the SVC library. Here in the previous code, in the simple SVM code, if you see means in the off we would not declare anything, but in here we have declared kernel, and the kernel which we are using in this code is sigmoid. And then we are just training the model by using the fit function, and we are calling the variables like train and Y train, X train and Y train. Then we are just testing the model by using the predict function, and the testing model result we are storing in an variable called Y underscore pred, and this Y underscore pred we are just using to display our performance metrics parameters. Then in order to display the accuracy, we are just using the variables like X test and Y test, and just we are running this code. The training accuracy, test accuracy we got as 0.3, that is 30% is got. So the with sigmoid the SVM is kernel, the SVM is not providing better results. So we can also just check some other parameters like precision, recall, F1 score and support. You may also see in this in that case also the same thing, like it is not providing better results. So in order to provide better results, we can see what to do. We can just import a grid function, so that thing we can see in our next video. So previously we saw with the test size as 20%, right? So we can just check with 30% of testing and 70% of training, that to just check whether any improvement is there. If there is some decrement only, already it was 0.30 but now it's 0.22 only. So now we can just decrease our test size, and just we can check whether there is all definitely there will some variations, but it varies for everything. So here also it differs. You can see it's 20. While working with 20%, it's 30 accuracy, and also the other parameters like precision is also changing. Uh, so this is the SVM code with sigmoid parameter, sigmoid kernel. The sigmoid kernel, SVM will already will show 1%, that is 100%. But when while using with sigmoid kernel, the accuracy is less. So we can conclude that sigmoid kernel is not producing better results in SVM. So in the next video, we can just see with another kernel, which is the poly. Thank you.